All right, let's pull back the curtain on the internet. We're going to look at the invisible but totally essential rules that make our whole digital world work. I'm talking about network protocols. So let's just dive right in.
You ever stop to think about it? You send a message, it gets there instantly. You search for something, click a link, and bam, the right info just appears. It seriously feels like magic, right? But it's not. It's actually a perfectly coordinated dance. So how in the world does your computer speaking your language get understood by some random server on the other side of the planet? Well, to answer that, we gotta go back to the very beginning and look at the huge communication problem the internet had to solve first. Here's the thing. At their most basic level, computers just don't speak English, or any human language for that matter. They talk in ones and zeros. They have no idea what "please show me a cat" video means. And that right there is a massive gap between us and them. Just try to imagine it. Millions of devices all screaming digital noise at each other, all at the same time. Without some kind of rulebook, it would be pure chaos. Data would just crash into other data, get lost in transit, or show up as a jumbled, garbled mess. You wouldn't have an internet. It just couldn't work. So how do you fix that? How do you bring order to all that potential chaos? Simple. You create a universal language that every single machine can understand. And that's where this key idea comes in, a network protocol. Think of it like a rule book. It's just a set of instructions that every device agrees to follow. And that simple agreement, that's the master key. It's what lets a brand new smartphone in Tokyo talk to a 20-year-old server in Berlin without anyone in the middle telling them what to do. It's the secret sauce behind the internet's insane, decentralized growth. And what's wild is that this isn't some crazy abstract idea. You actually use protocols all day, every day. Think about it. Human language is a protocol. We agree on things like grammar and what words mean so we can understand each other. Well, machine protocols do the exact same thing, just for data. They set rules for how information should be formatted and sent so that every device is playing from the same sheet of music. Okay, so we've established that these rules exist, but what do they actually do for us? How do they make the internet, the internet? Well, you can think of protocols as the ultimate quality control managers for the internet. First, they make sure your data gets where it's going without any mistakes. That's accuracy. Then, they figure out the fastest possible route for that data to travel. That's speed. They also scramble your private info to keep it safe. That's security. And finally, they make sure your connections stay solid from start to finish, and that's reliability. So, let's meet some of the most important players on the team. You've definitely seen these letters before, right? HTTP, TCP, IP. They're not just a random alphabet soup. Each one has a very specific job. You can think of IP as the postal service. It gives every single device a unique address. TCP? That's like sending a package with tracking and delivery confirmation. It makes sure everything gets there in one piece. And HTTP is like the actual language written on the letter, the thing that lets your web browser understand what the website is trying to say. Okay, so we know the rules and we know the players. Now let's see how they all come together in something you probably do, 100 times a day. The second you type in a website address and hit enter, you kick off this lightning-fast chain reaction. First, a protocol called DNS acts like the internet's giant address book, looking up the name of the website and finding its real numerical IP address. Then, TCP jumps in to open up a nice, stable connection to that address. And finally, HTTP, or the secure version, HTTPS, goes and fetches all the website's data, the text, the images, all of it, and brings it back to your screen. And the crazy part? This whole dance happens in the blink of an eye. And through all of this, there's a silent guardian working in the background. Those security protocols, especially that little S you see in HTTPS, are working overtime to encrypt your data. That means if you're buying something online or logging into your bank, these rules are scrambling your information into a secret code so that no one else can possibly read it. All right, so we've seen what they are and how they work, but let's zoom out for a second and talk about the so what. Why does any of this really matter? It really comes down to this, and it's incredibly simple. Without protocols, devices can't talk to each other. And if devices can't talk to each other, well, there's no network. There's no internet. Period. So by getting a handle on this one concept, you're not just someone who uses the internet anymore. You actually understand its core operating system. You get the language, the grammar that allowed this amazing decentralized global network to just happen. So the next time you load a web page or send a message, just for a second, think Think about all those silent, invisible protocols working perfectly in the background. They are the real foundation, the unsung heroes of our connected world. Makes you wonder, doesn't it? What other invisible rules are running our lives every single day?